Let us talk about the next example. Okay. The width of rectangular swimming pool is 8 feet more than the depth. The height is 16 feet more than the depth. The pool holds 1,365 cubic feet of water. Find the dimensions of the pool. So in this case, unlike the first example, here we need to consider first independent and dependent variable. The independent variable here is the depth, okay, the depth of the pool, while the width and the length will be the dependent variable. They will depend on the depth, okay? So from the first sentence, the width of rectangular swimming pool is 8 feet more than the depth. So yung last na na-mention na dimension, the depth, will be your x, okay? And then your width, the representation for the width will depend or use x, which is the depth. That's why I can erase this one already. We're done with the first example. Okay, because most of the problems in the activity, you need to consider independent and dependent variable. Okay, from the statement, the width of the rectangular swimming pool is 8 feet more than the depth. So you will start by letting x be the depth. Okay. So the rectangular swimming pool is x deep. That is the depth of the pool. And because of the statement, the width of the rectangular swimming pool is 8 feet more than. 8 feet more than. So whatever the depth, which is x, from the phrase more than, that means add 8, because 8 feet more than. Okay? That's why we write x plus 8 as the width. And then for the length, we will be considering the statement, the length is 16 feet more than the depth. So you start again with the depth, which is x, and then length is 16 feet more than. So 16 feet more than the depth. That is the depth. Okay, so here are the 3 dimensions represented by polynomials. And you also know that the volume is 1,365 cubic feet. That is the volume. And we follow the same steps, just like in problem number 1, and we can be able to find for the dimensions of the pool. Let us try this one. So we will now write the equation for the volume. So we can start with the depth as x times the width x plus 8 times x plus 16 equals the volume is 1,365. And then distributive property first, x squared plus 8x. We have a binomial times another binomial. Use FOIL method, first terms, x cubed. Outer terms, 16x squared. Inner terms, 8x squared. Last terms, 16 times 8, 128. 128x equals 1,365. Combine the 2 terms which are similar. We have x cubed plus 16 plus 8 equals 24 x squared plus 128x. We cannot transfer 1,365 from right to left. It will become negative. We have x cubed plus 24x squared plus 128x minus 1,365 equals 0. We cannot divide them by with any number because not all terms are divisible by one number. So we stick with this polynomial equation. Now we have this last term, 1,365. We apply the rational root theorem. It tells us that the possible roots are factors of 1,365. So here are the possible roots. It can be 1. 2 is not a possible root because 1,365 is not divisible by 2. But 3 can be a root because 3 is a factor of 1,365. Another is 5. You can also use 7, and then 13. And can be big numbers, but the most visible roots are present here in this list. Okay. We do not try 1, 3 because they are very small and the other two are very big. We try 5. So usually nasa middle yung answer. So we try 5. Let us use synthetic division. 5. Using the numerical coefficients 1, 24, 128, negative 1,365. Synthetic division, bring down 1. Then multiply. 1 times 5 equals 5. Write the product here, add 29. 29 times 5, 145. 145. And then add again. We have 13, 7, 2. 273. And then multiply again. 273 times 5. 1365 is the answer. 273 times 5 is 1365. And then add 0. That proves that x equals 5. Or 5 is one of the roots. Fundamental theorem of algebra tells us that there are 3 roots. And then, but at this point, we can actually check if 5 is the answer. How? By replacing it in the given. So, if the depth is 5 feet, 5 plus 8 will be the width, 13 is the width, and then 5 plus 16 is 21 is the length. Let us try to multiply them. 5 times 13 times 21. So 5 times 13 equals 65 times 21, 1365, which is correct. Okay, so even without solving for the other 2 roots, you already proved that the answer is 5. But if you want to have a tangible proof that indeed the other 2 roots are not the solutions for x, we can use discriminant b squared minus 4ac. This will show us that the 2 other roots are both imaginary numbers. Imaginary numbers can't be the value of the dimension. B squared is, b is 29 minus 4, a is 1, c is 273. 29 squared is 29 times 29. $841. 841 is the value of 29 times 29, and then minus 273 times 4. 1092. So smaller minus bigger, it will give us a negative result. It will be a negative number, which is negative 251. Negative 251 is the discriminant. So this negative number tells us that the other 2 roots are both imaginary numbers. They can't be the value of x because they are imaginary numbers. It cannot be the dimension of the swimming pool. So 5 is the correct result or value of x. So to answer the question, what are the dimensions of the pool? The pool is 5 feet deep, 13 feet wide, and 21 feet long. Do you have any questions for this example? Hello, do you have any questions in this example? Hindi required yung discriminant sa solution, especially if your last part is x cubed. You will only use discriminant if it is quadratic, x squared. So if the last part is x cubed, you stay with yung checking by replacing the answer with the given. And if you're able to multiply them and the result for the volume is correct, that proves that the value of x is correct. Enough na yung pag-check by substituting the value of x. You will only use the discriminant in quadratic equation. For cubic or any other polynomial equation, discriminant is not applicable. Any other questions? Okay, so this lesson gave us the realistic view that polynomial equation is applied in word problems and some situations that pertain to dimension of objects or things. And if the given dimensions are expressed in polynomials, we can use our knowledge in polynomial equation, solving polynomial equation through the different methods that we learned. We have the synthetic division, the factor theorem, remainder theorem, as well as the fundamental theorem of algebra, as well as the rational root theorem. And here we have discriminant, lesson in grade 9. All of them are integrated in order to successfully get um, the dimension of the object in the problem.